So this lesson, 8-3, is what I went over yesterday in class. For those of you that were lucky enough to go on a science field trip to the Academy of Sciences, I hope you had a great time. So what we did yesterday, or Tuesday in class, was that we reviewed just the first part of lesson 8-3, which is graphing ax squared plus bx plus c. And basically, we spent the rest of the time taking the quiz. So if you were absent yesterday, what you're going to do is you're going to have an opportunity to get the homework in class, work on the homework, and even if you have a chance to watch this video in advance, then you can work on your homework. So anyway, let's get started. So lesson 8-3 is on graphing. F of x is equal to ax squared plus bx plus c. I want to remind you that in lesson 8-1, we learned about the parent function of f of x being equal to x squared. In addition to learning about the parent function of f of x is equal to x squared, we also learned about what happens when I have a coefficient a in front of the x squared. We learned about when a is negative. We learned about when a is a fractional number, so a sits between 0, so it's going to be greater than 0 but less than 1. We also learned about what the shape of the graph is when a is greater than 1. So just to remind you that when I have f of x where a is negative, when I draw a coordinate plane, that my parabola is reflected across the x-axis. We also know that when, and I'm actually going to draw this directly on this graph, that when I have an a value that is fractional, that's a positive fractional number, that if I have f of x is equal to x squared, let's just say that this is f of x is equal to x squared. Obviously my a is positive, so here's my parent function of f of x is equal to x squared. That when I have a fractional a, that my parabola is wider. So this creates a wider parabola. In other words, it is more horizontally stretched than my parent function. It's translated wider. And therefore, when I have a value that's greater than 1, I see something else that happens to my parabola, and that it becomes more vertically stretched. And I'm going to draw that in green, just like that. And therefore, this becomes more narrow. In other words, we are vertically stretching my parabola. So that's what happened in lesson 8-1. And you graphed a whole bunch of different graphs relating to that. Then let's take a look at what happened in 8-2. In 8-2, we had the parent function of f of x is equal to x squared, most definitely. But then all of a sudden, we did something. We had f of x is equal to ax squared plus c. And we needed to remember that that c shifted. In other words, it translated my graph either up or down along the y-axis. Okay, so it shifted it up or down depending on whether I had a c that was positive or a c that was negative. Okay, so obviously shifting up was positive and shifting down was negative. So we did, again, you did a lot of graphing in your homework relating to these two lessons. Well, now let's look at what we're doing in lesson 8-3. In 8-3, all of a sudden, we are still going to have my parent function of f of x is equal to x squared. But now what we're going to do is that we are going to layer on the complexity of that f of x is now going to be ax squared plus bx plus c. So now look what we've done. We've gone from x squared to ax squared plus c to ax squared plus bx plus c. Well, if you want to sit and make a t-table, that's great. And I encourage you to do that. But this is going to become very tedious. This is going to become a very inefficient, it's tedious and it's inefficient way to graph. And we're going to learn in 8-3 a nice shortcut. And I want you to just think for a moment, if I were to draw coordinate plane, okay, and we know from the coordinate plane that when I draw a parabola, that we learned that we have this axis of symmetry that goes right down the middle of our graph, or parabola. And it split this in half. It's a mirror. We also learned about the bottom of our graph, or the top of our graph, is the vertex. And the vertex has got an ordered pair of x comma y. And that vertex of x is the point which is considered my axis of symmetry, remember? And you've been labeling your graphs with vertexes and axes of symmetry. Okay, well now, this is all nice because we've had our vertex be on the y-axis. We've also seen that our axis of symmetry is always x is equal to 0. Well, what happens if my parabola shifts? Or it shifts, or it shifts, right? And you've got all these different parabolas. Well, this is going to be very inefficient to create an x and y table, try to figure out all the points that work to make that shape. So in 8-3, we're going to learn about how to find the vertex and find the axis of symmetry really quickly in order for us to be able to get a point and then also realize that I could also get a y-intercept point, which is going to help me figure out what the shape of my graph is. And then what I'm going to be able to do with these pieces of information is maybe plug in one or two more numbers here in order to be able to get my graph. So that's what's going on in 8-3. But let's start with the most basic premise. And let's figure out how to get the vertex and the axis of symmetry. So here's our note packet page. You're going to see here's our learning objective, graph a quadratic function in the form ax squared plus bx plus c. As part of this lesson, we're also going to learn about maximum and minimum values. Well, I just want to throw it out there real quick. Think about, what does maximum and minimum mean? This means big, or the largest. And what is minimum? It means small, right? So, thinking about parabolas just really quick, if I were to draw a coordinate plane, right? And if I were to draw a parabola, which type of parabola would show a maximum value? Well, a parabola, it looks like a frown, right? Because is that not my tallest point right there? That's the maximum amount. And subsequently, I could do the same thing with the minimum right here. That's my smallest value of my graph. This is the minimum value. So we know that the low point in this graph is my vertex. We know that the high point in this graph is my vertex. So if you think about drawing that dotted line through it, what am I going through each time? I'm going through the y value, the y-axis right there, going through the y. So my maximum value is my y value, and my minimum value is my y value. So this is the lowest point on my parabola. And what else do I know? That my maximum is going to be the highest point on my parabola. And remember what I said, I could draw a line through them, so therefore I'm intersecting the y-axis. So my highest and lowest point are always y is equal to. Okay, so think about now we've got everything kind of for our vertex. Let's just write that down, right? Vertex is either the highest point or the lowest point. And what do I know about a vertex? It's x comma y. Okay, and I can again draw my parabola, and I can have this be my vertex right there. Or I can come over here and draw another coordinate plane. And if I go up, I know that that's my vertex right there. Okay, so think about what I'm talking about, right? Points and points. Points, x and y. Well, and then what do I know about my axis of symmetry? Well, my axis of symmetry goes right through, I draw it right here, goes right through my vertex, right through my vertex. And what do we know about the axis of symmetry? Well, the axis of symmetry is my x value. It's my x value of my vertex. And now, therefore, let's connect the dots. And my minimum or maximum value is my y value. Okay, so now we've got it all squared away and taken care of. We know what the x and y value are, the vertex. We know that the axis of symmetry is my x value. And we know that the maximum or minimum value is my y value. So hopefully that's going to help clarify when we come up with all the terminology around maximum, minimums, vertex, axes of symmetry. Okay, moving on. Let's turn the page and let's take a look at this picture up here. So this picture is what we're talking about. Okay, so look at, there's our vertex. Here's my axis of symmetry. Here's my y line, here's my x line, or my x and y axis. And I want you to take note. Take a look at this right here. Here's the y-axis, and look where my parabola crosses the y-axis. That's the y-intercept. This is the y-intercept. So notice the y-intercept is when x is 0. So that means when I go up and I plug in 0 in for the x here and here, if I multiply anything by 0, I get 0. So what am I left with? I'm left with that y is equal to c, which is what I've got right here. So this last term in the standard form is c, which is my y-intercept, which is really nice because you know what my favorite number is 0 when it comes to graphing. So I could easily figure that out. And then the only other thing that we've got is we've got this formula. And the formula to find the vertex and axis of symmetry is x is equal to minus b over 2a. Well, b and a come from ax squared plus bx. And I could actually find my axis. There's my axis of symmetry is the x value. And then how do I find the vertex? Well, if I know what x is, I can go back up here and plug it in and get the y. Okay, so let's see what that looks like. So here's a worked out solution from the book. This is example 1. And if you want to go back after I've worked through this and read through this, again, please do so. But what I'm going to do is I'm going to go ahead and jump to example right here where we're going to do it together. So this is the exact example. This is example 1. And what we're supposed to do is we're supposed to find the axis of symmetry and the vertex of the graph. And you're going to notice here that this is standard form. There's that ax squared plus bx plus c. And right above it, I'm going to write f of x is equal to ax squared plus bx plus c. Okay? So then all I need to do is I need to figure out what are the values of a, b, and c. So let's go ahead and plug those in right now. I know that a is 2. I know b is 8. And I know that c is negative 1. So write the equation for the vertex. Well, the vertex is x is equal to, that's the actual formula. We're not deriving the formula. I'm going to give it to you. The formula states that x is equal to minus b over 2a. Okay, so that's a formula that you need to know and memorize. And you will see it again next chapter in the quadratic formula. So now I'm going to substitute, meaning I'm going to replace the values of the equation for a and b and solve for x. So that's what I'm going to do right here. I'm going to say that x is equal to minus, because I'm taking that minus, I'm going to plug in 8 over 2 times a, which is 2. I'm going to go ahead and simplify. This is equal to negative 8 over 4, which I know that negative 8 divided by 4 is negative 2. So what did I just figure out? That x is equal to negative 2. So remember, what is x equal to? X is, think about my vertex. If I have x comma y from my vertex, and I've just figured out what x is, you guys remember that x is my axis of symmetry. So I just figured out the axis of symmetry for my graph. Okay, so what value did we just find? We found that x was equal to negative 2, and we know that x being negative 2, that's my axis of symmetry. Okay, so now the next question asks me, well, how do you find the vertex? So what I'm going to do is I'm going to replace or substitute x in, x is equal to 2, into my original equation of f of x is equal to 2x squared plus 8x minus 1. I'm going to substitute x. Every time I see an x, I'm going to replace it with 2, and I'm going to solve for f of x. And remember, what is f of x? F of x is equal to y. So let's go ahead and do that. So I'm going to write is equal to, so I could write f of 2 is equal to 2 times 2 squared plus 8. Oops, it's negative 2. Can't forget that. It's negative 2. It's going to change my answer. So 2 times negative 2 squared plus 8 times negative 2 minus 1. So I'm going to go ahead and simplify. And I know that order of operations tells me I've got to do negative 2 squared first. So negative 2 times negative 2 is positive 4. And 2 times 4 plus, and I've got 8 times negative 2, which is negative 16, minus 1. I'm going to continue to simplify. 2 times 4 is 8, minus 16, minus 1. So go ahead and continue to do the arithmetic. If I have 8 and I take 16 away, I'm left with negative 8. And if I have negative 8 and I take 1 more away, I get negative 9. So what is negative 9 equal to? Negative 9 is definitely my f of x, which is equal to my y. So now do I have an x value and a y value for my axis of symmetry? Absolutely. So going right here, my x comma y, I've got negative 2, comma, negative 9. So, did I do what I was supposed to do? Yes. Did I find the axis of symmetry? Absolutely. Did I find the vertex? Yes. So now, look at this. I've got a point. I actually know what the low point of my graph is. Negative 2, comma, negative 9. So I know that what? My graph looks like this. And I know right here at the bottom is negative 2 and comma, negative 9. I know that. So, not that we're graphing right now, but if I needed to, at least it gives me a starting point. Okay, so now, what we did in class yesterday is we actually did number 1. We found out that number 1 was not very friendly, and that you got a fractional number. So what I'm going to do is I'm going to actually ask you to do number 2. And what you're going to do is you're going to turn off the video, you're going to work through the problem, and then you're going to double check your work against mine. Okay, so you could see I've already worked through the problem, and what I did was, the very first thing, identify your A, your B, and your C, and go ahead and write your vertex formula, which is x is equal to negative b over 2a. I went ahead and substituted the values for a and b into my equation, and I got that x is equal to negative 3. Remembering that when I have an x value, that is my axis of symmetry. So now what I did with my x value is I went back to my original equation, and I substituted every time I saw an x, I substituted in negative 3 each time, and then I went ahead and simplified and did all the mathematics. So therefore, I got that g of negative 3 is equal to negative 4, and I need to remember that g of x is another way that I can name y. So I put negative 4 is equal to y. Therefore, now I have an x value and I have a y value, and I know that therefore my vertex is negative 3, comma, negative 4. So my suggestion would be is to go in and do number 1 on your own as a way to practice some more. And the answer at the end was 1/3 negative 1/3 for number 1. And for for number 3, the final answer, and I'm just looking my answers up in the book real quick, just so you have, it's another interesting, they're fractional numbers, so I'm going to put the answers down here so you can go in. It's 70 and 20.5. So because it's fractional, I think it's a good idea to try it, just because you're given negative 1/2, and it kind of forces you to kind of work with fractional numbers, which I think is always important in your math development. So that's what we covered yesterday or Tuesday class. Tomorrow when you come into class, again, we're going to finish up this lesson 8-3. We're going to do some graphing, and you're going to have time to work on your quiz. Okay, so hopefully you find this helpful.